NFPA 72, the National Fire Alarm and Signaling Code, doesn't specify a minimum mounting height for motion sensors used for lighting in the hallways of common areas in multifamily dwellings. Similarly, NFPA 101, the Life Safety Code, doesn't specifically address motion sensors for lighting in hallways. However, NFPA 101 does require in Section 7.76.3 that lighting shall be provided in all exitways and shall be maintained in reliable operation at all times. Also, Section 7.76.4 states that emergency lighting shall be provided for exitways, high-rise buildings, and areas of refuge. ANSI, ASHRAE, and IESNA Standard 90.1-2016, which is the energy standard for buildings except low-rise residential buildings, also doesn't specify a minimum mounting height for motion sensors used for lighting. However, it provides guidance on the placement and operation of occupancy sensors. Section 5.7.1.2 of ANSI, ASHRAE, and IESNA Standard 90.1-2016 states that occupancy sensors shall be placed in locations and shall be aimed and set to operate so as to maximize energy savings without interfering with occupant comfort or disrupting lighting for legitimate tasks. Section 5.7.1.4 states that occupancy sensors shall have an adjustable time delay with the default setting between 10 and 15 minutes. In conclusion, while there's no specific code requirement for the minimum mounting height of motion sensors for lighting in hallways of common areas in multifamily dwellings, it is essential to ensure that the sensors are placed in a way that maximizes energy savings, minimizes occupant discomfort, and does not interfere with the reliable operation of emergency lighting. There are additional considerations as well. Firstly, the mounting height may need to be adjusted based on the type of sensor and the size of the hallway. Secondly, motion sensors should be placed in locations where they will not be obstructed by furniture or other objects. Thirdly, manual override switches should be provided to ensure that lighting can be controlled manually if necessary. Fourthly, regular maintenance and testing should be performed to ensure that the sensors are functioning properly. When selecting and installing motion sensors for lighting control, especially in common areas of multifamily dwellings, it's essential to carefully consider several factors beyond just the absence of a specific minimum mounting height in the codes. These factors can significantly impact the system's effectiveness, energy savings, and user experience. Consider the type of motion sensor. There are several types of motion sensors available, each with its own advantages and disadvantages. Passive infrared, or PIR sensors, detect changes in infrared radiation caused by the movement of people or objects. These are generally cost-effective and widely used. Ultrasonic sensors emit high-frequency sound waves and detect changes in the reflected waves caused by movement. These sensors are more sensitive than PIR sensors and can detect movement even when there is no direct line of sight. Microwave sensors emit microwave radiation and detect changes in the reflected waves. These are the most sensitive type of sensor and can detect movement through walls and other obstructions. Dual technology sensors combine two or more sensing technologies such as PIR and ultrasonic to reduce false positives and improve accuracy. The coverage area and range of the sensor are also important considerations. The sensor should be able to cover the entire area that needs to be monitored. The range of the sensor should be sufficient to detect movement from a distance. The sensitivity of the sensor should be adjustable to prevent false positives caused by pets or other small objects. The time delay is the amount of time that the lights will remain on after motion is no longer detected. The time delay should be adjustable to accommodate different occupancy patterns. A shorter time delay will save energy, but it may also cause the lights to turn off too quickly, which can be disruptive. The mounting location is also a critical factor. Sensors should be mounted in locations where they have a clear view of the area to be monitored and where they will not be obstructed by furniture or other objects. Sensors should also be protected from direct sunlight and other sources of heat, which can cause false positives. Consider the specific requirements of the hallway. Hallways are typically long, narrow spaces, so it's important to choose sensors that are designed for this type of environment. Sensors with a narrow field of view are often a good choice for hallways, as they can help to prevent false positives from people walking by in adjacent areas. Consider the potential for obstructions. Hallways can sometimes be cluttered with furniture, decorations, or other objects. These obstructions can block the sensor's view and prevent it from detecting motion. When choosing a mounting location, be sure to consider the potential for obstructions and choose a location where the sensor will have a clear view of the area to be monitored. Ensure compliance with energy codes and standards. Even though there may not be a specific code requirement for the minimum mounting height of motion sensors, there are likely to be other energy codes and standards that apply to lighting control systems in multifamily dwellings. Be sure to check with your local building department to determine which codes and standards apply to your project. Consider the integration with other building systems. Motion sensors can be integrated with other building systems such as ASHRAE and security to improve energy efficiency and security. For example, the lighting control system can be integrated with the ASHRAE system to turn off the lights and reduce heating or cooling when a space is unoccupied. The lighting control system can also be integrated with the security system to trigger an alarm if motion is detected in an unoccupied area. The importance of manual override switches should not be overlooked. Manual override switches allow occupants to turn the lights on or off manually, regardless of whether motion is detected. This can be useful in situations where occupants need to override the sensor, such as when they are working in a space for an extended period of time or when they want to create a certain ambience. Regular maintenance and testing are essential. Motion sensors, like all electronic devices, require regular maintenance and testing to ensure that they are functioning properly. Be sure to follow the manufacturer's instructions for maintenance and testing. In addition to these factors, it is also important to consider the cost of the motion sensors and the installation costs. Motion sensors can range in price from a few dollars to several $100s. The installation cost will vary depending on the complexity of the installation and the labor rates in your area. By carefully considering all of these factors, you can choose and install motion sensors that will provide reliable and energy-efficient lighting control in the common areas of multifamily dwellings. In addition to the technical considerations already discussed, there are several practical aspects to consider when installing motion sensors in multifamily dwellings to ensure the safety, comfort, and satisfaction of residents. Firstly, consider resident feedback. Before installing motion sensors, it can be helpful to gather feedback from residents about their lighting needs and preferences. This can help you to choose the right type of sensor, the optimal mounting location, and the appropriate time delay. Consider the aesthetics of the sensors and their placement. In common areas of multifamily dwellings, aesthetics can be important. Choose sensors that are aesthetically pleasing and that blend in with the surroundings. Consider the placement of the sensors to minimize their visual impact. Ensure that the sensors are accessible for maintenance and repairs. Motion sensors will eventually need to be maintained and repaired. Ensure that the sensors are installed in locations where they are easily accessible for maintenance personnel. Provide clear instructions to residents on how to use the motion sensors. Residents may not be familiar with motion sensors, so it is important to provide them with clear instructions on how to use them. This can help to prevent confusion and frustration. Monitor the performance of the motion sensors and make adjustments as needed. After the motion sensors have been installed, it is important to monitor their performance and make adjustments as needed. This can help to ensure that the sensors are functioning properly and that they are meeting the needs of the residents. Address any resident concerns promptly and professionally. Residents may have concerns about the motion sensors, such as that they are too sensitive or that they are not working properly. Address these concerns promptly and professionally to maintain resident satisfaction. Consider the potential for vandalism. Motion sensors in common areas are susceptible to vandalism. Choose sensors that are vandal resistant and install them in locations where they are less likely to be vandalized. Implement a preventative maintenance program. A preventative maintenance program can help to extend the life of the motion sensors and prevent costly repairs. The maintenance program should include regular inspections, cleaning, and testing. Train maintenance personnel on how to maintain and repair motion sensors. Maintenance personnel should be trained on how to maintain and repair motion sensors. This will help to ensure that they can properly address any problems that may arise. Keep a record of all maintenance and repairs. A record of all maintenance and repairs can help you to track the performance of the motion sensors and identify any potential problems. By considering these practical aspects, you can ensure that the installation of motion sensors in multifamily dwellings is successful and that it provides a safe, comfortable, and energy-efficient environment for residents. To further elaborate on selecting the right type of motion sensor, consider the specific features and benefits that each technology offers in the context of a multifamily dwelling hallway environment. PIR sensors are generally effective at detecting motion from humans due to their body heat. However, they can be prone to false triggers if there are significant temperature fluctuations in the environment or if there is a direct line of sight to heat sources like sunlight or HVAC vents. In a hallway, it's important to position PIR sensors carefully to avoid these false triggers and to ensure they are sensitive enough to detect residents walking at a normal pace. Ultrasonic sensors, on the other hand, are not affected by temperature but are more sensitive to air currents and can be triggered by the movement of objects or even curtains. They are generally better at detecting very subtle movements. In a hallway, this could be an advantage in detecting people even when they are not directly in the sensor's line of sight, but it also increases the risk of false triggers from environmental factors. Microwave sensors are the most sensitive and can detect motion through walls, which can be both an advantage and a disadvantage. While they can detect movement before someone enters the hallway, they are also the most prone to false triggers from activity outside the hallway, making them potentially unsuitable for high-traffic areas. Dual technology sensors, combining PIR and ultrasonic or microwave, offer the best of both worlds. They require both technologies to be triggered before activating the lights, which significantly reduces the risk of false triggers. These are particularly useful in hallways where there may be a mix of environmental factors and human activity. When considering the coverage area and range, it is important to map out the hallway and identify any areas where coverage might be limited due to corners, doorways, or other obstructions. In long hallways, multiple sensors may be needed to ensure complete coverage. The sensitivity settings should be carefully calibrated to avoid false triggers while still ensuring that the lights turn on promptly when someone enters the hallway. The time delay setting is crucial for balancing energy savings and user convenience. A shorter time delay will save more energy but may cause the lights to turn off too quickly, especially if someone is moving slowly or stops momentarily. A longer time delay will be more convenient for users but will result in less energy savings. A good compromise is typically between 5 and 15 minutes, but this should be adjusted based on the specific usage patterns of the hallway. When considering the mounting location, avoid areas where the sensor could be easily obstructed by furniture, decorations, or other objects. Also, consider the height of the sensor. Mounting it too low could make it susceptible to vandalism, while mounting it too high could reduce its effectiveness. A typical mounting height is between 7 and 8 feet, but this can vary depending on the specific sensor and the layout of the hallway. To comply with energy codes and standards, be sure to check with your local building department to determine which codes apply to your project. Many jurisdictions have specific requirements for lighting control in common areas of multifamily dwellings. These requirements may include minimum lighting levels, maximum time delays, and mandatory use of occupancy sensors in certain areas. When integrating the motion sensors with other building systems, consider the potential benefits of connecting them to the HVAC system. By turning off the lights and reducing heating or cooling when a space is unoccupied, you can significantly reduce energy consumption and lower utility bills. Also, consider integrating the motion sensors with a security system. This can provide an added layer of security by triggering an alarm if motion is detected in an unoccupied area, especially during off-hours. Manual override switches are essential for providing occupants with the ability to control the lights manually when needed. These switches should be easily accessible and clearly labeled. They should also be wired in such a way that they do not interfere with the normal operation of the motion sensors. Regular maintenance and testing are crucial for ensuring that the motion sensors are functioning properly. This includes cleaning the sensors to remove dust and debris, checking the batteries, and testing the sensitivity and time delay settings. It is also important to keep a record of all maintenance and testing activities. When addressing resident concerns, it is important to be responsive and professional. Listen carefully to their concerns and try to address them in a timely manner. If a resident is experiencing problems with the motion sensors, try to troubleshoot the problem over the phone or in person. If necessary, schedule a service call to have the sensors inspected and repaired. In addition to these technical and practical considerations, there are also several other factors to consider when installing motion sensors in multifamily dwellings. Consider the potential for liability. If someone is injured as a result of a malfunctioning motion sensor, the building owner or manager could be held liable. To protect yourself from liability, be sure to install the sensors properly and to maintain them in good working order. Consider the impact on property values. Properly installed and maintained motion sensors can increase the value of a property by reducing energy costs and improving security. However, poorly installed or maintained sensors can have the opposite effect. Consider the long-term costs and benefits. Motion sensors can save money on energy costs, but they also require an initial investment and ongoing maintenance. Be sure to weigh the costs and benefits carefully before making a decision. By considering all of these factors, you can make an informed decision about whether or not to install motion sensors in multifamily dwelling. You can also ensure that the installation is successful and that it provides a safe, comfortable, and energy-efficient environment for residents. Remember to always consult with a qualified electrician or lighting contractor to ensure that the installation is code compliant and that it meets your specific needs. It is also important to choose a reputable manufacturer and to purchase sensors that are designed for the specific application. In conclusion, while there is no specific code requirement for the minimum amount and height of motion sensors for lighting in hallways of common areas in multifamily dwellings, it is essential to consider a variety of factors to ensure that the installation is safe, effective, and compliant with all applicable codes and standards. These factors include the type of sensor, the coverage area and range, the sensitivity settings, the time delay, the mounting location, energy codes and standards, integration with other building systems, manual override switches, regular maintenance and testing, resident concerns, vandalism, preventative maintenance, training of maintenance personnel, record keeping, liability, property values, and long-term costs and benefits. By carefully considering all of these factors, you can create a lighting control system that meets the needs of your residents while also saving energy and reducing costs. Also, remember to research the local codes.